Hey everybody, in this video we're going to talk about graphically solving a system of linear equations. But before we do this, let's talk about what our options are for how many solutions we can get when we're solving a system of linear equations. Now, when we're talking about solutions to systems of linear equations with two variables, we can have one unique solution, and that's where the lines intersect at one point. Okay, because lines go on forever in both directions, they're never gonna loop back and touch again. So they can have one unique solution. They can end up having the same slope, but have a different y-intercept, which they're gonna be parallel always because they have the same slope. So they're gonna have no solution. They're never gonna cross. And then they can also, here's an example of infinitely many solutions when we have two different lines. These are two different lines, even though they end up being the same line when they're graphed. Okay, they represent the same line. All points are in common, so we're going to have infinitely many solutions. And in another video, we'll talk about what these solutions mean as far as inconsistent, dependent, and all that stuff. So for now, let's go ahead and go over graphing these. Okay, so what's the easiest way to graph lines? For me, it might be different for you, it's fine, but for me, the easiest way to graph lines is to get it in the form y equals mx plus b. So this line is going to end up being, after we subtract 3x, y equals negative 3x plus 6. The reason I like that is because negative 3x plus 6, the y-intercept is at 6. And then I'm going to go down 1, 2, 3, and over 1, like this. So this becomes my line, and it's a little tricky to get this to look super good on the computer. But I'm going to end up with something like this. Okay, and now my other line right here, let's graph it in purple. It's going to have a y-intercept of negative 2 and then a slope of negative 1/3. So I go down 1 and over 3. Oh, what do you see? I see that my lines are going to intersect at this point right here. So graphically, I can say, hey, I can find that point pretty easy. This point right here is the point 3, negative 3. So that becomes the solution to my lines, or my system of linear equations. So there's one example. Let's go ahead and talk about another. Okay, so for these, how do I get this into y equals mxb form? I'm going to subtract x and then divide by 3, negative 3. So I'm going to end up getting y equals 1/3 x minus 1. So now I'm going to graph it. So I'm going to have a negative 1 in y-intercept, and then I go up 1 and over 3, like this. Oh, that last one, second to last one, wasn't over 3. I only went over 2. There we go. And this is one of my lines. That's my first line right there. The second line, I'm going to have a y-intercept of negative 2, and then I'm going to go up 1 over 3, up 1 over 3. So you can see my slopes end up being the same here. So if my slopes are the same, that means they're never going to intersect. I have the same slope, I have different y-intercepts, so I have no solution on this one. Okay, next. Right, this first line is already in y equals mx plus b form. Now let's take a look at this second line real quick and get it into y equals mx plus b form. So I'm going to subtract a negative x, or add x. I'm going to add x to both sides and get 2y equals x minus 6, and then I'm going to divide by 2 on both sides, and I'll get y equals x minus 6 all divided by 2, which is 1/2 x minus 6 divided by 2, which is 3. So what do we notice between these two lines? They end up being the same line. So I have negative 3 as my y-intercept and up 1 over 2. But that's for both lines because they end up being on the same line. So I have infinitely many solutions, because I could pick any point on one of those lines or along both of those lines, and it will be a solution to both equations. If I plug any of those points into both of these equations, they'll be solutions. So that's how we graphically solve a system of linear equations.